In section 5.2, we're going to discuss applications of similarity, and that really is just code word for word problems. But don't worry, they're not very difficult, and what you should remember is that anytime we're dealing with similarity, we're writing a proportion when we're talking about the sides, right? So that's what's going to happen today. We're just going to be writing proportions and solving them, but we're going to have to draw our own pictures because it is a word problem. All right, so the words you're going to see in today's word problems are things like scale models, blueprints, maps, or shadows. And so again, if you don't have a picture, I think it's helpful to draw a picture, but that is optional. I'm not going to be grading your picture, so if you don't need one, you don't have to draw it. You need to set up a proportion and solve it. And what's important that you understand is sometimes the units will be different. So especially when you're dealing with things like scale models and maps and blueprints, one of the units might be in something more like feet or meters, and then when you're dealing with something shrunken down a lot, then they might convert over to something like centimeters or inches. And so when you're dealing with different units in a proportion, you do not need to convert units. And I'm going to show you an example, I think it's in example 2, why you don't. Some of you that'll make sense, and for some of you it won't. But please remember that you don't ever need to convert units. Okay. So in example 1, it says you're dealing with a scale model. So this is kind of like a scale model problem. Gwen scans a photo that is 4 inches wide by 6 inches tall into her computer. If she scales the height down to 3 inches, how wide should the similar photo be? So again, like I said, I like to draw pictures, and the first picture I'm going to draw is a larger photo, and then I'm going to draw a smaller photo because I know she scales it down. Okay? The word tall, and when you think about the word tall, think about the word height. Tall and height are kind of the same thing, right? They're like synonyms for each other, tall and height. And so when I read the first piece of information that they gave me, the first photo, the original photo, was 4 inches wide by 6 inches tall. So I'm going to put the 6 inches on the height, and I'm going to put the 4 inches on the horizontal dimension. Now you could certainly switch that if you want, but make sure when you label the second rectangle, the second photo, you keep you keep it the same. Whatever you did on the first one, you got to do the same. Okay. So it says she scales the height down. Again, I'm using the vertical dimension as my height, so she's scaling it down to 3 inches. So I'm going to put 3 on my vertical dimension, and they're asking how wide is the similar photo. So I'm going to put an X down there because that's the question. That's what we don't know. So if we were given the picture back in yesterday's lesson, what we would have done was say, well, we'll compare the 6 to the 3 because those are both the heights. So think about that when we're doing word problems. You have height over height, and you have height of original over scaled photo, okay? So on the other side of the equal sign, you have to do the original width over the scaled width. So if you're going to go original height over scaled height, you have to go original width over scaled width. So you'd go 4 over X. So that would be how you would write the correct proportion. On the other side, it'd be the original width over the scaled width. And that's really important for proportions, that whatever you do on one side of the equal sign, you have to do something similar on the other side. So you can't put the scaled width on the top on the other side if you put the scaled height on the bottom on the original side. All right, so we're going to cross multiply this. We're going to get 6x equals 12. We're going to divide by 6, and our x equals 2. And so it says, how wide should the similar photo be? It should be 2 inches wide. Now this one, everything was in the same unit, so the units should not have been confusing. And this one, I'm going to guess that some of you would say, I don't even need to write this proportion because you can see that 6 went to 3, which is half. And so the 4 needs to be halved also, and that would go to 2. And some of you would be able to do this without a proportion. And that's certainly fine on a problem like example 1. But when we get to example 2, you're going to see that's not always the case. You're not always going to be able to just to look at the numbers and know what's happening. So I definitely want you to be able to write the proportion, okay? So let's try it again. Example 2 is a blueprint problem. And it says the Lincoln Memorial is 57 meters long and 36 meters wide. On the blueprint for the memorial, the length is 3.8 centimeters. So you'll notice that in this problem, we do have the units being different on the original, the Lincoln Memorial, the actual, versus the blueprint. But you do not have to convert. All right, it says, what is the width of the memorial on the blueprint? So again, it's really a picture similar to an example 1. You have the actual Lincoln Memorial, which is going to be big, and then you have the blueprint. And if you know what a blueprint is, it's just a scaled down version of the original. So the blueprint's going to be a smaller version of the actual Lincoln Memorial. And so use whatever conventions you want to for length and width. It really doesn't matter as long as you keep it consistent. So I'm going to put the 36 meters on my shorter dimension and my 57 on my longer. The way I drew this, because is the Lincoln Memorial long? Now I don't remember. Is that the really tall one or is that the long one? I can't remember. Anyway, the way I drew it, I'm just labeling it so my shorter one is my width and the length 157 is longer. So I just put that down on the horizontal. All right, so it says on the blueprint, the length is 3.8. So again, I put the length here as the 57, so I have to put the 3.8 also in a similar position on the horizontal dimension. And it's asking what is the width on the memorial, so I'm going to put an X there. All right, so remember again, when you set up your proportion, whatever you do on the first side of the equal sign has to match what you're doing on the second. So I'm going to put 36 over X. So I put the width of the actual memorial over the width on the blueprint. So on the other side, I'm going to do that same thing. I'm going to put the length of the actual over the length on the blueprint. All right. So that's what that should look like. So if we multiply, we're going to get 57x equals, and I forgot to do the multiplication again, so 36 times 3.8. 36 times our 3.8, we're going to get 136.8. And so we're going to have to divide that by 57. And we're going to get 2.4. So our x will equal 2.4. And think about what your dimensions are. You're solving for the blueprint, and the blueprint's in centimeters, so it's going to be in centimeters. So on these problems, I will take off 4 units that are incorrect. And so that's another reason why I think it's important to label your picture so you can see that if the x is on the rectangle with the word centimeter on it, then of course the x that you solve for would also be centimeters. But let me talk about why the units work. Again, you might not understand this, and that's fine, but just for those of you who might understand, let's analyze just the units, all right? Instead of putting the numbers into the proportion, let's put the units into the proportion. And so the 36 was meters. We were missing units at the bottom. We didn't know what they were. The 57 was in meters, and we knew the 3.8 was in centimeters. So if you multiply units, just like you multiply variables, you'd get, numbers, you'd get x times n equals meters times centimeters. I'm just multiplying the units as if they were variables or numbers. We're solving for the units on x. So we would divide by m, the m's would cancel, and we would have x equals centimeters. This is what's called unit analysis, dimensional analysis. It's something that you should be doing in chemistry. I'm sure that some of you have done this in chemistry. And that's how you know if you set up a problem right. And that's how you would also know what the final dimensions would be on the answer. So again, if that didn't make sense, that's fine, as long as you remember what I put at the top of the notes, that the units can be different. You do not need to convert. And then remember what I said when you're doing the problem. If the missing dimension is on the shape that you put centimeters, then your dimension that you're solving for would be centimeters. So it's not necessary that you truly understand what I did over here in the highlighted yellow, but you do need to understand how to get the units right. All right, so those are very similar. Scaling something down or creating a blueprint, those are like taking a dimension and making them smaller. And notice again in example 2, if you didn't set up the proportion and solve it, I don't think most people would be able to look at this problem and say, well, 3.8 and 57 have a certain relationship, so I can just mental math my way over to the x. You're not going to be able to do that. So make sure you can write the proportion. All right, finally, not finally, we got 2 more. A shadow problem is a very typical ACT problem. Shadow problem is also setting up similar figures. So let's kind of draw this out. A cell phone tower casts a shadow that is 72 feet long. So think about a shadow. A shadow's on the ground. And so I'm going to put a shadow just as a horizontal line on the ground. And that is 72 feet. And this is the situation with the cell phone tower. While a tree standing nearby that is 27 feet tall casts a shadow that is 6 feet long. So my tree, I have a situation where I have a tree, it is 27 feet tall. Tall to me means height, so we're going to make that vertical. So that's going to be 27 feet. And the shadow, again, shadows are on the ground. That's going to be 6 feet. What the question is how tall is the tower? Well, I don't even have that represented. Tall, again, means height, so let me put a missing height here with an X on it. And so these are definitely not drawn to scale, but what we have kind of is like a little triangle. You could complete this off here with a little triangle, and what we're trying to solve for is one piece of the triangle. So it's sort of like creating similar triangles. And so again, I'm going to make sure I do the same thing on both sides of my equal sign. I'm going to compare the heights. So height of the cell tower to the height of the tree. And so on the other side, I've got to go back to the original shape and do the length of the shadow over the length of the tree. So always go back to that original shape. Since the X was on the top, then the 72 should also be on the top on the other side. If we cross multiply correctly, we're going to get 6x equals, and I actually did do this math, 1,944. And if we divide by 6, our x is going to be 324. This is another one where the units are all the same, so it's pretty obvious that the units would be feet. Sometimes it's, like I said, not as obvious like when we were in example 2. All right, last one. We have a map that is drawn so that 1.25 inches represents 100 miles. About how many miles does 1.5 inches represent? All right. So in reality, we're saying that the map, for every 1.25 inches, you're going to go 100 miles. So I don't really draw a picture on this one. I guess I never thought about that. But for me, there's not a real picture that I could draw. Maybe one of you guys would want to draw a picture, but I can't really think of a good picture to draw. So I'm just going to say I'm going to go 1.25 inches represents 100 miles on the map. So what I did was inches over miles, right? A map, and or think of it as you did the map over the actual mileage. Right? On the other side, let's do that same thing. It says about how many miles does 1.5 inches represent? Well, 1.5 again is on the map. So the 1.5 belongs on the top. And how many actual miles does that represent? That means the x would be on the bottom. If we multiply this, cross multiply, we'll get 1.25x equals 150. If we divide by 1.25, our x will be 120. And again, if you look at the units, what's happening? On the top, we have inches, and on the bottom, we have miles. On the other side, on the top, we, again, should have some matching up here. We have inches, and so the bottom dimension should be a miles. We're missing the miles. All right. So this is all about setting up a proportion. We're actually using similarity because it's the same idea as similarity. So set up a proportion and solve.